told you to use L1 and L2 and run a weighted average for that life insurance payout? I totally know that. But I like to break it down component by component too, so you can see what's actually going on, especially after leaning over and seeing what Beth was doing with the probability times the payout. So what I've done here is I've basically done the same thing that the mu would happen in your TI, how the mu would happen in your TI. I've taken each payout from the policy and multiplied it by the likelihood of that. And what I want to do is what average did you guys get? Say it again, Chestnut. Was it positive 93? No, that's a big difference, isn't it? The average you end up getting is negative $93. Actually, let's put that over here. Let's put that over here. Say that again?
You guys
probably a decimal off somewhere. The big idea though, is that it's around negative 90 bucks. That's the big idea. Which means, on average, what is happening to people that buy this policy? They're losing money. How come?
They're not dying.
Because most of them are staying alive and not getting hurt. That's the idea. That's the idea of insurance. This has to be negative, doesn't it? It has to be negative because they have to create a pool of finances to draw from for those who do die. And they also have to pay things like bills, overhead, salaries, things like that. What I want to do is I want to break down these individual pieces. So friends, what is this 9640 times this 0.00269? Just this piece right here. Was that about 20?
25.9.
Love it. I'm going to put it approximately equals here if it's okay with you guys.
26.
About 26 bucks. It's roughly 26 bucks. Which means there is 26 bucks per year being contributed to this average by the people that die. In other words, people that die are getting 26 bucks on average, contributed to all the people that have the policies, including those who don't die. This is on average. That's a positive though, right? Interesting, that's a positive. How about these folks right here? The ones that become disabled, we're taking about 12%, it's about 200 bucks-ish.
196 points, so 100.
Good, we'll call that about 200-ish. 200-ish, just an ish. Now, wait a minute, this seems very strange. How can we be averaging 226 bucks positive, but having this guy come out to be negative? Because what does this work out to be, friends? Right, you're essentially taking 4/5 of this, aren't you? What's negative 360 times that bad boy? Around 3. There you go. That's what's driving the average down. The large probability attached to a negative value is driving the average down. So even when you have these positive weights, they're not positive enough to overcome that negative. How is this like Chuck-a-Luck? The large negative probability overpowers the small positive ones and results in a negative net average. Now in this, it's gambling, so they're keeping the lights on in Vegas. There, it has to be negative because the insurance company has to stay in business. But that's the reason why it's negative. It has to be negative, doesn't it? And I had you calculate the standard deviation too, but by all means, please just ignore it. It's huge and ridiculous. I don't even know why I had to do it. I was going to give you a point, I guess, 3 point. Now, take a few moments and read the next example. I love this one. It's one of my favorites. It's actually happened in New York back in the late 90s, early 2000s, I believe. Check it out. I'll turn the camera off for now. Turn it back on in a second.